So I guess we'll go ahead and get started. This is Sherry Jessen. I'm with UNITA. Of course, this is my first webinar, so be patient with me. I'm learning the ins and outs of Zoom webinar, but wanted to come on today to talk to you a little bit about random orbital sanders and orbital sanders in general and how to choose them, how to maintain them, what's the best sander for what you're doing. And just a general overall look at sanders in particular. The topics for today's seminar or webinar is orbital sanders versus random orbital sanders. What's the difference? Two, we'll go over the different sander sizes. What sander should we choose for each job? Now with the coming on of the electric sander and then being a little bit more durable, which is better for your operation? Is it electric or pneumatic? And finally, we'll go through the maintenance of the random orbital sander, or the pneumatic, the do's and don'ts, some of the problems that we see daily. I'm the hand sanding tech at UNITA, so I get into checking RPMs, and we do different applications as far as looking at how do we maximize our sanders and what we can do to make them last longer, work better, and help you to get a better product. Sanding is a big part of the wood industry and our finish. And if we don't have optimal air and the different, all the components together, we get problems in the finish room. We get swirls. We have different finishes that you can actually see the problems in. First of all, let's talk about two different types of sanders. You've got an orbital sander or a fixed rotation sander. This sander there's no random pattern to it. It is generally a little bit more aggressive. I've used these a couple times in automotive. I don't see many of them in woodworking. I have used one or two in solid surface to blend, seams. When we need to really get aggressive, if the seam is really raised or, there's a lot of glue in between, sometimes it's just a little bit hard to do with the random orbital sander, especially a 3/32, which we'll get into a little bit later. But a fixed rotation sander tends to be a little bit more aggressive, and you get more of a swirl pattern out of a fixed rotation sander, which is one of the reasons we don't see it in the wood industry as much. The most widely used sander right now in the wood industry, I would say, is the random orbital. There's, different sizes, but predominantly the 5-inch. And you can see the picture of ours on there. It's just a standard 5-inch random orbital sander. Which sander should I choose? So looking at a job, there's so many different types of sanders out there now. You have square, you've got round, you've got 3-inch, 5-inch, 6-inch, 8-inch, 11-inch. And it really looks, to determine what sander you need, you have to look at the job you're doing. In the cabinet shops that we see, the 5-inch and the 6-inch is predominantly what we use, predominantly the 5-inch, I should say. But, the 3x4s come on, the square sanders are starting to come on because we see more of the doors being shaker style. So with that in mind, it's kind of depending on your job is depending on what sander you need to have. And sometimes you'll need multiple sanders. The 3-inch orbital, I actually really like this little sander. I've sold a lot of them in solid surface. And it is the perfect sander for the bowls. With a 5-inch and a 6-inch, when you hit the side of the bowl, you're only going to hit just a narrow piece on either side of the backup pad. So it's really hard to blend them. Where the 3-inch will actually sit flush all the way around. It's also really good for bull nose. I've tried it a couple of times in the coves, and the coves aren't as easy with the 3-inch. It's still, because the backup pad is still a little bit stiffer, you need a softer backup pad. And I still go back to using, a 5-inch with a 6-inch pad where I can get up in the cove. But the 3-inch on the bowls and on bull nose, it's fantastic, and it's very easy to handle. It's small in your hand. The 5-inch orbital, like I said, we see a lot of those in the wood industry, predominantly all we see. 3/16, 3/32. What's the difference? Well, you got two different patterns, random patterns in the swing on the backup pad. The 3/16 swings a little bit wider, and it gives you a little bit wider swath. And it also gives you a different pattern, swirl pattern. If you start to see swirl marks, you're going to see a longer, elongated swirl mark. And the 5-inch is the 3/16 tends to be just a little bit more aggressive than the 3/32. The 3/32 I lean towards. I call it my finish sander, and the reason being is with the 3/32, it's a tighter random pattern, so it's a tighter swath, and you get a very tight pigtail type swirl if you start to see them in your finish or in your sanding, and it's a lot easier to remove and to maintain your sanding position with the 3/32 when you're finishing. 6-inch, same random patterns, 3/16, 3/32 swaths. So those two pretty much mirror each other. The biggest advantage with the 6-inch, especially on solid surface, is the size of the backup pad and the ability to cover more ground than the 5-inch. But with the 6-inch on wood, you tend to get more swirls early on. It tends to be because of the bigger pad, the bigger swath, you tend to see swirls earlier on. And with swirls, it's really, especially on wood, it's kind of a breakthrough period when you have to remove cross grain. You're sanding, and you have a period where you're sanding, you're getting the cross grain out. But once you get to a certain point and the swirls start, there's no way to stop them. I mean, it's going to swirl from there on out. It's kind of a break. You hit a breakthrough, and once you break through, the swirls just appear, and it's really no way to stop it. So it's one of the reasons why when we're sanding, random orbital sanding, we're very careful to make sure that the side of the table is lit up and that we can see what we're sanding. And when we get to the point where we feel that the cross grain has been removed, then we can stop before we start with the swirls. Again, the 8-inch fixed rotation sander, just a circular motion. It seems to be a little bit more aggressive. With the 8-inch, I see it more in, like I said, automotive. I see it in, I used it a lot in aviation. We used it on the wings on aircraft. And that's where, early on in my career was where I focused a lot of time at. And so we needed something more aggressive. If you get a fixed rotation sander on a piece of wood, there's no way that you're not going to end up with swirls. It's just a huge, you say 8-inch and you don't think it's that big till you pick it up, but the 8-inch is a good size backup pad. And it is rotating at the same RPMs, but it's just a much more aggressive pad. And then the 11-inch, most of this is, the gym sander, as you guys know, and it's in solid surface. So with the solid surface, you have such a much larger area to cover, and it is hard to blend and not create corn rolls. With the corn rolls, you'll start to see, as the light shines across, you'll start to see the pattern in which you sand. And, it's one of the reasons why we try to do figure eights or we do in random patterns, but you still can see everywhere you move the sander. With the 11-inch, especially on a large piece, the 11-inch eliminates that. And so that's kind of been the go-to with solid surface. I think I have a question. Let me see. It looks like one sander is metal and one is plastic. Does that make a difference? Yes, it does. With our sanders, our 5-inch and 6-inch, and our 3-inch are aluminum housing. And the reason we've chose aluminum housing is it absorbs vibration a little bit better. Okay, so when you've got a composite body and you start to sand, especially for somebody that's sanding 8-10 hours a day, holding that sander, your hand starts to go numb almost. And it's very, very hard to just continue to sand at that point. You know, you lose control of the sander at times. And and we've also had a lot of people that told us, you know, there's a lot of the hand sanding is done by women. And so I've had a lot of women tell me, you know, I've ended up with carpal tunnel syndrome because of the vibration and holding the sander for long periods of time. So with the aluminum housing, it actually absorbs the vibration. I find when we sand, ours are lighter, are a lot lighter than the composite bodies to me. I don't, you know, sand necessarily 8 hours, but testing and doing different things, you know, I'll sand for an hour or so at a time. And, you know, I don't feel the numbness in my hand that I do if I'm using a composite body. So that's kind of the difference of why we went with the aluminum housing, and I feel like it's a little bit more durable. I feel like that the chances of the aluminum housing cracking is a little bit better. Let me see. I got another. Let's see. I think that's all the questions right now. All right. So again, choosing the right sander depends on, again, what are you doing? Are we working on wood? Are we working on, you know, solid surface? Are we doing, you know, large areas? And again, is it something where we're going to drop a bowl in? So there's a lot of different options today. The sander field is growing every time I turn around. Let's see. The second set that I have up is our square sanders. You'll see there's two different sizes. The 3x4 is what we have seen over the last, I'd say 6-7 years, has just, the sales have skyrocketed on this sander. The reason being is because we have shaker doors. You can drop in a shaker door and go corner to corner and not miss that corner swath and have to come back with a, you know, a sanding sponge, a block, or anything like that. If you can do that, it speeds up the process, the sanding process. The biggest problem that I see in cabinet shops with the 3x4 is on white wood. There's a couple of things that I'll tell you. On white wood, it's because it is a fixed rotation. So, I mean, I call it a straight orbit. And I know that doesn't make sense, but it's just orbiting. There's no random to this sander. So as it's orbiting, it actually will catch and dig, and it will swirl. I've tried, like, I don't know, maybe 10, 12 different types of sheets and film and different ones, and there's really not one that's not going to swirl on raw wood or white wood. It will reduce. We can reduce the swirls if we go to a pad saver, and I'll tell you, without the pad saver, you will hate the sander on raw wood, just because it tends to grab. As you start to sand across the surface, it will grab the wood and it'll skip. And when it starts to skip, it's hard to control. The pad saver works kind of as a shock absorber. So it allows it to move a little bit, you know, smoother across the wood. But really and honestly, I haven't really found anything that stops the swirls with the 3x4, unfortunately. I've had a lot of people that say, you know, I don't like it on white wood. I use it on white wood. I use it on raw wood. But when I sand with it with a coated abrasive, you know, either a sheet or a film sheet or you know, any type of abrasive, I usually follow up with either a maroon, depending on how deep the swirls are, either a maroon non-woven or Unilon, or a gray, depending on how deep those swirls are. If it really got aggressive, I've got aggressive swirls on it, I'll go to the maroon, because that's about a 320 grit. So I get into that, and we'll get into those more when we get into the abrasive part of the hand sanding webinars. But just to give you a little tidbit, you know, that's a big problem with the 3x4. You get to the finish room, this sander is by far a must. The 3x4 is just, it will speed up the time in which you spend doing either crown molding or doors or face frames, because it's small. Again, it's small in your hand, easy to control, and it's square. drawer boxes. You can drop in, go corner to corner on a drawer box, where before we were having to sand with a 5-inch and then come back with a block, or using just going straight to a block and doing all of our finish sanding in between coats. The sand on the side of it is a 3 2/3 by 7, which is a larger footprint. One of the things that, especially in the finish room, that I'll get, somebody will tell me, gosh, the 3x4 just takes me so long. It's such a small footprint. And, you got refrigerator panels, and you got other, products, even larger cabinet doors. I have some, my pantry doors are really big, and it would take, forever to get in and sand corner to corner with those guys. But if I use the 3 2/3 by 7, it's like, the 3 2/3 by 7 is actually, it's the same rotation, but it's a larger footprint, right? So it still allows me to go corner to corner without getting out a sanding sponge or a sanding block. Or it's, it will allow that, the difference in the aggressiveness. It's a little bit more aggressive. And so I have a lot of people that buy the 3 2/3 by 7 for repair work, where you've got to go all the way back to raw wood. You got through the stain, you got through the sealer, and all of a sudden you got all these problems and it doesn't look right. So we've got to take it all the way back to raw wood. This sander, especially like I said, in a square situation, shaker doors, where I've got to go corner to corner, this one is a little bit more aggressive, and it allows us to do that. So there's, two really, really good choices, either one, but I mean, the 3x4 to me, it's a must in the finish room. You have to have it. And everybody now has pads to fit them. And so it's becoming more and more prevalent. Every time I go in, I see more and more people using them. Let's go. Okay. Electric versus pneumatic. I get this question a lot, because electric sanders, one, it's expensive to purchase and put in a huge compressor system, right? To run, especially in a large shop, to run all the tools that require air. And then if you're running multiple sanders, or if you're running, you got your finish room running on air, and everybody's trying to pull off the same air, it sometimes will cause issues. So with the electric sanders coming out now, it's a little bit different, right? So we've got some different options with the electric sanders, but still the pneumatic sanders, they're what the staple is of the industry, because they've been around so long and so many people use them. So key points to consider when you're looking at pneumatics versus electric. The first thing with a pneumatic, they're designed to run at 12,000 RPMs. Optimally, you don't want them to drop below 10,000. You start dropping below 10,000, the pad starts to slow down. You get a drag on the pad, and what happens is, one, you wear out the abrasive grain a lot quicker. Two, you give the time, it's drawing much more dust, and you're loading so much more into your abrasive. So you're going through a lot more abrasive product, right? So we want the sander to be running, we'd like to see 12,000 RPMs, but we don't want to go below 10,000. That's just a big, that's the breakthrough point. You got to have it at least at 10,000 RPMs. They operated on 90 PSI. We do go in and, like, when I go in and check in a plant, I want to make sure that I got 90 PSI going to the sander. I don't want to go over that, because if you pump too much air through the sander, you're going to tear up the internal parts of the sander. It causes problems in the internal parts inside the motor. They're designed at 90 PSI, and there's a reason for that. It consumes 3.2 cubic feet per minute. So you can look at your compressor and say, okay, well, I've got this running, this running, this running, and you can hear the compressor kick on. If it starts to kick on way too often, you're running at one, you're not getting optimal air going to the sanders. Two, you're running up your energy costs. So that's kind of the trade-off. So you've got to look at it and say, do I go to a bigger compressor, or do I, go to electric sanders? And, but that's some of the key points when we're looking at, is it possible to run a pneumatic sander in my shop? And so that's that, we definitely need, you definitely need to look at that. Electric sanders today. All right. So in the years past, we'd go to Home Depot, we'd go to, Lowe's, anywhere, any of the home improvement stores, and you could buy a little random orbital sander. They sit up pretty high. They have a button at the top that turns on. The backup pad is usually a 4-screw backup pad. They're really hard to find. You sometimes can find them back in the home improvement store, but a lot of times not, right? So it's like, with that being said, where do we go from there? So about 4 years ago, the new electric sanders started coming out. And I've run them a lot. I run them here at home because I don't have a compressor. And I do a lot of testing on products. I I sand cabinets for friends. I sand myself, I bought this house recently. I've been sanding my cabinets. So I use our electric sanders a lot. The electric sanders are great for, small to medium shops where you do have a reduced air supply, because it is a way to get the torque that you need without, going through sanders every month. And the sanders before were, they were AC driven sanders. They had brushes in them. The backup pads, like I said, are pretty hard to find. I've not looked recently in any of the stores, but in the past, I know they've been hard to locate. I've had people tell me they just go out and buy a new sander rather than trying to find the backup pad. But they were relatively inexpensive. The electric sanders today are a little bit more expensive. And the reason being is because they're DC driven. So if you look at the sander on the page, one, you see a longer elongated handle. And the reason for that elongated handle is because everything is contained in that handle. So all the electrical components to allow that sander to plug into the wall and transfer from an AC current coming out of the wall to a DC current going into the sander is in that handle. So there's no longer at one point there was a little side box and you would plug into the box and then the box would plug into the wall and the current was switched in that little box. Now we've put it in the handle. The drawback is that, if you hammer down on this handle, on the sander for a long period of time, it can overheat. The good news is if it overheats, it's simple. It's a simple fix. It's a series of buttons. You unplug it, series of buttons, reprogram it, plug it back in, 2 more buttons, and you're going again. But that has been one of the drawbacks of putting it in the handle because it does allow the heat right there at the motor. But outside of that, they work fine. They are brushless. One of the big failures of the electric sanders of the past were the brushes. There were brushes inside the sander. Those would wear out. Once those wear out, the sander doesn't turn anymore. And then, of course, the biggest problem with both pneumatic and electric sanders is heat. When we create heat, we drive it up through the center, through that center nut and the counterbalance in the sander. In the center of the sander. So that's where all the heat goes up into the motor. With electric sanders, we want to keep it running as cool as possible, like I said, because they do have a tendency with all the electronic components right there at your hand, you can heat them up quick. So we want to keep that running as cool as possible. So if you look at the top picture, you'll see the counterbalance is at the top. The top and bottom counterbalance both have a fan blade. The fan blade is turning at the same RPMs as that counterbalance, okay? So it's working just like what we're saying. It's a fan. So it's blowing the cooler air into that area to try to keep that center nut cooler. I've actually ran, a sander, a pneumatic sander without the fan blade. I've ran it and taken the backup pad off and had somebody try to touch it. The center nut it's hot. I mean, you can't touch it. With the fan blade on the electric sanders, I can take off the backup pad. I'm not telling you hold your hand on it and, for any period of time, but you can actually touch that center nut and without getting burned. And that's huge because that's one of the biggest problems that we have with sanders today. Pneumatic sanders how do we maintain them? How do we get them to last? You know, with the electric sander that we were just looking at, the new electric sanders last, oh gosh, if you really, you know, take care of them and don't dog them, I mean, those sanders will last, I can't even tell you how many years. I mean, that's what they're designed to do. It's what we have seen in the, you know, the advancements in the electric sanders. With the pneumatic sanders, though, you know, they're a lot less expensive, and you know, they tend to get dropped. You're laying them on tables. People aren't as apt to be careful with them, I guess, is what we should be. You know, and as our sanders start to wear, that we lose RPMs, and when we start losing RPMs, or we start having problems with you know, the bearings going out, and you can hear the bearings going out, all of that causes problems in the sanding. And when we're sanding on raw wood, what we don't see in raw wood, if we don't have the table lit properly, what we don't see when it gets to the finish room, it's like glares at you. When I started, you know, I start in a shop, the first thing I do is always I talk to the finish guy. And the reason I talk to the finish guy is because I want to know what problems he sees, because he's the last guy to see it. He's got to push it out the door as a finished product, and it's got to look good. So when I talk to him, I'm like, what are you seeing? And he can usually give me an idea of what he sees in the wood as it comes in and what he has to fix if it's a stain job. You know, paint is, with the amount of paint today, it's not as crucial, but you still have your stain jobs where it is. And so you can tell by the different swirls, or the amount of swirls, or the way the swirls are laid out on the workpiece, whether you've got, you know, a slow RPM sander, or if you got problems with your sanders, or if it's just over sanding, or, you know, you can look at the actual pattern and tell. And that's huge, because you want to be able to fix, when you go into your custom shop, you want to be able to fix what's broken. And so to fix it, we start where we know we're going to see the problem, which is in the finish room. Again, go back to heat. Heat is the major cause of failure in pneumatic sanders. I mean, we drive so much heat through that center nut into the motor and into the bearings that it just almost cooks everything in there. If you don't lubricate the sanders, and I mean, I've had people say, oh, you know, they told me I really didn't need to lubricate it. You need to lubricate your sanders. I mean, you've got metal parts, you've got, you know, some the phenolic veins in there. As they come out in that plastic housing, they're running against that housing. Without lubrication, that's friction. And all you're doing is eating away at that housing. And eventually that little vein will pop out, and it'll be wide enough that it'll turn sideways, and it shuts the sander off. Nothing will turn at that point. And there's no just pull this part or just fix this. You got to pull the whole motor. The motor's done. So, you know, I stress constantly, if at the end of the day, if you take a small eyedropper bottle, put some, you know, machine tool oil in it, and just 2 drops at the air intake. I mean, you just 2 quick drops, plug your air hose back in, hit your paddle, let it creep overnight. Just hit it, let it turn, so it'll start to swing the oil around. It'll just creep through the veins and all through that overnight. And the next morning when you get there, your sander will sound much better. You'd be surprised how different a dry sander sounds from a sander that's properly lubricated. It is the sound of it is night and day. The other thing that I see a lot is the filter cap. And I'm gonna actually go pick up this sander so you can see what I'm talking about. And I have an arrow there, but this filter cap, and I have a vacuum hose on this, but this filter cap is huge. I've been in shops where guys have actually removed them, and they say, well, it causes the sander to run faster. Technically, probably you will pick up a few RPMs, maybe, you know, 1,000, maybe you'll get it up to 13,000. But again, the sander's designed at 12. We probably shouldn't be running at 13 anyway. One of the first 101 sanding classes I took was you want to sand consistent and slow. You know, you don't want to try to whip the sander. So speeding up the swath or speeding up the RPMs on the sander really doesn't do you any good, because you shouldn't be moving the sander very quick anyway, right? But it will pick it up a little bit because you got more air, you know, there's nothing restricting it, right, coming out. But the problem is that filter cap is there for a reason. As we depress the lever right here, when we depress that, that becomes, the air comes, it pushes it out, right? And it's shoving the air out. We're shoving the air coming in, it's going through the sander, and it's going right out that filter cap. As we, when we release that lever, that area becomes a vacuum, right? So we release the lever, and all of a sudden we just sucked in all the dust, all the particles, everything that we just sanded, we just sucked it right into the sander, and it went right into the bearings. As that builds up in the bearings, it just becomes sludge, and your bearings lock up. Well, yes, you can replace bearings in a sander, but no more than maybe once or twice at the most. As you pull bearings, you start to stretch out the housing, and they run loose, and you never get the full RPMs that you need out of that sander, and it never runs properly. So if we can prevent pulling bearings, that's what we want to do, right? So the filter cap is huge. You know, we've kind of looked at different sanders, and you can look inside. There's usually a little nylon filter that goes in between there. You should only have one, and that way you get good air. If it's too clogged up, then you're not gonna get good air, and you're not gonna get the RPMs you need out of that sander. So that filter is very, very important to the proper maintenance of that sander. And then the last thing is like we talked about a while ago, 90 PSI. If I don't have 90 PSI coming in, I'm not going to get 12,000 RPMs, or I'm sorry, out of the square one, that would be a 10,000 RPM sander, right? I'm not going to get what I need. If I've got too much, then I'm pushing too much air through, and all I'm doing is just tearing up the motor. I'm running way too much air through it. So it's imperative that we look at how much air we're getting into the sander, which is why we test it. When we first get there, I always test RPMs and how much air I'm getting in the lines coming in. I want to make sure that I'm at 90 PSI. So those things are really important in maintaining our pneumatic sanders. It's what makes our sanders last. It keeps you from replacing them every 6 months or every year. I've got people that they tell me they buy them every 6 months, and I'm like, well, if you install a proper maintenance schedule, your sanders are going to last you much longer. People drop them, they knock the filter cap off. Well, it won't hurt. I'm just going to sand this one little piece. It won't hurt just to do this one little piece. It will hurt, because every time you do it, again, the dust is going in the filter and it's getting into the bearing. So getting that set up, a good maintenance schedule, either with the people using your sanders, or getting, if you got a maintenance department, getting with them, that's really important. And again, like I said, the motors on these things can be pulled. You can replace the motors. I would say I wouldn't replace them more than maybe once or twice at most, because the housing just starts to stretch, and they just don't seat well anymore. Like, you just can't get them the motor and the bearings to seat well afterwards. They may fit in and they may lock in, but they don't seat well. So that's the other thing, is if we can maintain them and keep them running, then we don't have to repair them as often. We do have a repair. We do actually repair some sanders. So you need a dozen. So I know that they can be sent in and we can work with them. Again, hand sanding is it's a huge part of what we do daily. It's what keeps us going. Wide belt sanding is where we start. When you always set your color at the wide belt sander, but if you don't have good hand sanding to follow it, you're not going to get a good product out the end of the shop. It's going to be a mess, especially in stain. You have to change. You're choosing your proper size, the proper configuration, looking at what jobs you're doing. If you've got solid surface, I would look at a 6-inch sander, because it's got a bigger footprint. I would look at the 11-inch if I'm turning out big tops. It'll speed your time up. I mean, one of the big things with what we do with, you know, having the different types of sanders available for our customers is we want to look at how we can drive down labor costs. How can we get the product from point A to out the door with, you know, as few abrasives as possible, the best finish possible, and yet in a timely manner. And the finish room is always kind of the bottleneck, because either you're repairing what happened prior to, or you've got a lot of hand sanding going on in the finish area. You know, you're finish sanding by hand. And with the use of the 3x4s and the 5 inches and what we can do now with the abrasives, we can speed that up and we can get it out the door much, much quicker. So, you know, and again, by following these basic guidelines and schedules, that your sanders will last you. You will spend a lot less on sander purchases than, you know, if you continue just to not follow a maintenance schedule. And some people choose to, but it's really important. And I find for me, the hand sanding, you maintain the wide belt machine because we spend, you know, hundreds of thousands of dollars on wide belt machines, but yet we look away from the hand sanding and the hand sanders, the orbital sanders, because it's just a couple $100. Oh, it's just a couple $100. But if you look at it and what you're doing is, every couple of months or every 6 months or every year, you're buying 5, 6, you know, orbital sanders. That's money that's going out of the shop that really wouldn't have to be. And that's kind of why we developed our tech program. Anyway, if you have any questions, please email me. I sit in front of the computer, especially right now with COVID going on. You know, all of us have kind of been at home and just hunkered down and doing the social distancing thing, but things are starting to open up. So I know we'll be traveling soon. We will be happy to get out to some of you guys' shops. If you have any questions, email me if you would like to know more about how we test your sanders. I'll be happy to go through that and, you know, what tools we use to do so. But thank you so much for coming along with our webinars.